Okay, so hello everyone and welcome to this lesson on forecasting. Today we're going to discuss the different aspects of forecasting and why it is important for companies and organizations in general to be able to forecast and predict the future. This is part of the industrial engineering program at the American University of Sharjah, and this is chapter 4. So, first of all, what is forecasting? Forecasting is an art and science of predicting a future event. And an art is something that is subjective. It's not like hard science, like 1 + 1 = 2. No. An art is something subjective. It's different for everyone. Everyone has different opinions for art. However, for science is a hard science. It's something that's fixed. 1 + 1 = 2. Laws of the different laws in physics and math, all of these different sciences. A science is something that's objective, it's not subjective. It doesn't depend on the person. So forecasting is a science and an art, trying to predict what's gonna happen in the future. And of course, there's always gonna be uncertainty in a prediction. This is most seen and applied in the stock market. Also, as we said, in companies are trying to predict. Also, there are different types of forecasting that we're gonna discuss. For example, technology forecasting and different types of forecasting where people try to predict what are the new advances that's gonna be and happen in the future. And it is another definition is the scientific process of estimating a future event by casting forward past data. So it uses past data to cast and predict the future. And that's basically forecasting. It's that simple. Okay, so there are different forecasting type horizons, 3 different types. First one is short range, and it generally lasts less than 3 months. It's predicting, like I say, customer habits, who is going to purchase a specific product in the next 3 months, or what are the sales of a company is gonna be in the next 3 months. We're gonna try to predict that, or the next month, next week. Since this is short range, it's gonna be from 1 week up to 3 months, and can go up to a year. Also, we can predict also the scheduling and other things like that. So job scheduling. Also, we have medium range forecast, which is typically from 3 months up to 3 years. And this is also goes for sales, also the stock market. Some people try to predict the stock market with people who day trade. They try to predict the stock market and using some metrics that can help us to predict that. We're gonna discuss in this presentation. So it's helpful for budgeting and setting a budget for the next, let's say, year based on this forecast that we are having. Also, we have long range forecasts, which is more than 3 years. We are predicting sales, needed materials, budgets, labor, and all of these things, needed resources for the future 3 years. So we are predicting what is the demands that we are going to have in order to provide the resources needed for this demand. And this is typically for new products and, for example, new locations, opening a new location, opening a new branch, or opening a new site for a company, and also for research and development departments. Now, moving to the types of forecasts, there are three main types. The first type is the economic forecast, and this is forecasting different types and different business cycles, something that deals with money, since it's economic. So say inflation rates, money supply, house starts. So try to predict inflation rates for the next month. How I'm gonna do that? I'm gonna do that using the inflation rates for the previous month or the previous 2 or 3 months, previous year. Try based on the previous data, past data, I'm gonna try to predict future data. And how this is how forecasting is basically done. Also, we have money supply. So we, for example, we're gonna predict how much do we need as for the budget in the future. So we're gonna try to predict that also, and housing starts, and etc. And we have also the second type of forecast, is the technological forecast. Okay, and the technological forecast predict rate of technological progress. So we can predict how the technology in a specific field are going to advance in the future, and the impacts of development of new products. So technology is rapidly advancing, and it's in a rapid pace, and we need to always keep track of that advances and be able to understand and be able to predict what's going to change in the technological sector, because we need to keep up with that. Otherwise, we're gonna go distinct. And for one example is Kodak. Kodak was the leading company for the technology industry, camera stuff like that. But then Nokia was the dominating was the dominating telephone company. However, now it's no longer that, and because they have not adapted, they have not had not sure, maybe a technological forecast, have they had that or not, and for that they went completely distinct, and you rarely see someone who have a Nokia today. And also third, demand forecast. So we're gonna predict the demand in order to predict also the resources that we'll need, and also predict sales. So this is a video on technology forecast. I can have a link. Okay, so now we're gonna discuss the 7 steps in forecasting. So there are 7 steps to forecasting that we need to follow, and it starts with determining the use of the forecast. So why do we need to forecast? Do we need to predict? So do we need to predict a technological forecast, or predict an economical or demand forecast? Why are we predicting, or are we predicting to, yeah, so these different types, based on these types, why are we predicting? And also second, select the items to be forecasted. So what do we want to forecast exactly? We need to make sure what are we forecasting. So for example, are we forecasting a specific change in the market, like for example a change in a specific technology like the iPhone or the iPads, how are they going to develop? So maybe other competitors can try to come up with better solutions. So for example, Samsung can come up with better solutions for this thing. So and this next, we need to determine the time horizon for the forecast. So this is either it's gonna be short term, medium term, or long term. They are the 3 time horizons. Fourth, we're gonna select the forecasting model. So which model? There are different models we're gonna go through that are that can we use for forecasting, and then gather the data needed to make the forecast, and then make the forecast and validate and implement the results. I'm gonna go through these steps now. So first of all, let's touch into some of the realities of forecasting. So first of all, forecasts are seldom perfect. Unpredictable outside factors can easily impact the forecast. So yes, we have a forecast, we can predict, we can, but some predictions that are somewhat certain, but at the end, any forecast, any prediction is gonna have uncertainty. It's gonna have unpredictable outside factors that maybe were not considered, or some unpredictable events. So forecasts in general are just like approximations. They are not something that we rely on. Otherwise, everyone will forecast, for example, the stock market, or forecast that a specific stock will gonna increase in value and then they're gonna buy it. Or for example, it's gonna decrease in value and then they're gonna sell it. And whoever makes these forecasts are gonna be the wealthiest. But we know that that is very hard to do, to predict what specific stock or price or anything in general is going to be, because in general there are different many variables that someone may, or many unpredictable events that can happen. So this is relative forecasting. And also the thing that is that most techniques assume an underlying stability in the system, and this is usually not the case. Sometimes gonna have instability in the system. This will imply that maybe future events will be different than past events. So and also family and aggregated forecasts are more accurate than individual product forecasts. So when we forecast a family of products, or a group of things, a collection, these forecasts tend to be more accurate than individual product forecasts. So now we are moving to so now moving to forecasting approaches. There are different forecasting approaches. These include qualitative methods, and different methods in which you can forecast. In general, qualitative and quantitative. You can quantify thing, or depend on the quality of the thing. And when there is no data, so when we don't have data, this is qualitative, so it's very vague and it depends. It's not like something that we can have real life data supporting it, or numbers that support it. So it's all based on intuition and experience. How is the for example, the customer feeling about a product, or how do we feel the company is doing now? If we don't have numbers, then it's gonna be based on intuition. But if we have numbers, then we're gonna move to a more quantitative approach. So it involves intuition, experience, and so you're gonna try to, for example, forecast sales on the internet. How are you going to do that? Maybe you can quantitative that and have some quantitative approach to that, but in general it's gonna be qualitative, because you are based on your intuition, you are predicting. So it's generally used for new products and new technology where no past data is already existing. So for example, for the new Apple Vision Pro, this is a qualitative approach would be more appropriate for it, because it's a new product and you don't have any past data to have a quantifiable forecasts. So you cannot predict the sales. Yeah, so then we go to, if we have data, we have real life data that we can use, then we're gonna have quantitative methods. And these quantitative methods are used when a situation is simple and when a situation is stable. So we are assuming stability in the system, and historical data should exist. So we need data. We need data in order to make quantitative forecasting. So, and we are also assuming that the system is stable and past data are going to imply future data or similarity. So that's what we are. These are the two conditions. So having historical data and also assuming that the data are stable for forecasting. So this can be used for existing products. For example, Apple can use this for the sales of their iPhones, Apple Watches. Samsung can use this for their Fold, we call it Samsung Fold product, and also for any other kind of technology like cars, Camry, Altima. These companies, Toyota, Nissan, Mercedes, all of these companies can use it. So and it involves mathematical techniques, which are we going to cover. Okay, so first of all, we're gonna have an overview of the qualitative methods that we can use. So first of all, there is the jury of executive opinion, and this is basically a poll opinions of high-level experts. So here the keyword here is expert. We need high-level experts to give us opinions, and sometimes augmented by statistical models. So it can be high-level experts and also augmented with statistical models. So how is this gonna happen? We can go to, so let's say we want to predict how is our new product, like Tesla is launching a new product which is a smart assistant, let's say like Alexa, or let's say they want to launch a smart product that's better than Alexa. Okay, so they don't have previous data on that because they don't have any, they never launched a product as such. So they're gonna go to experts, for example, who developed this product or worked on projects on these products, and they're gonna ask him, what do you think of this? Do you think it's gonna make a lot of sales? Do you think it's not gonna do anything? And from there, they're gonna ask more than one expert. They're gonna go for other people also who know about this product. Like there are other also there's Alexa, and there is also there are other companies who developed like a home assistant. I just can't recall them for some reason. So I know Alexa, and there are different companies. So they can go to these companies and contact them directly and ask them for advice on this. And they can give them excellent advice since they worked on it before, and even they can go to other people and they are experts. So then they get the opinions, they get the numbers from these experts based on let's say the prototype of the thing that Tesla developed. Okay, and based on that, they're gonna give them numbers, predictions of future sales, and then they take the average of all the numbers and then use that, and this is the jury of executive opinion. So this is an opinion from different people, and this is the first type of qualitative method. The other type, we have Delphi method, and this is a bit different. This is more interesting. I think it's more of a better way to predict. So it is a panel of experts queried iteratively. So we are iterating the query. So basically, let's explain this. I know it's vague. So basically, let's say we are talking about the same product, the Tesla product. So now Elon Musk wants to develop something like Alexa. He wants to compete with Amazon. Okay, so now he's gonna go to the experts on this topic, and he's going to ask them regarding this, and he's gonna get all the opinions exactly like what he did in the first type. Okay, but now this time he's gonna get different opinions, and he's gonna ask for justification for every opinion. So for example, the first person is predicting sales of $100,000 in the first year. The other guy, and he's listing his reasons why. He's maybe thinking that this product is gonna be, if it's like a prototype, it's gonna be very competitive, it's gonna compete, and it has more features and more, the brand and stuff like that. He's gonna have his justification. This is one expert, and now they're gonna go to the other expert, ask him the same. He will give a number, let's say 200,000 per year, and he's gonna have also his justification. And they're gonna go to third expert, fourth, and so on. So each expert has his own numbers, his own justifications, his own opinions on the matter. But then this time, instead of taking the average of all the numbers and all the opinions, no, this time they're gonna take all these opinions and send them back to the experts. So they're gonna take the first package, let's say, or the first group of opinions, and they're gonna send them to each expert again. Each expert, they're gonna send it, and then tell him that this is what others said, and now I want you to do some research and give me an updated prediction based or forecast based on this new data. And now he's gonna do his research, and every expert is gonna do this again. He's gonna do his research, stuff like that, based on other experts' data. But the thing is that, yeah, so he's gonna do the research based on other experts' data, and then they're gonna send back the new modified prediction, and they're gonna do this again, maybe 5 to 10 times. Gonna iterate, and that's why it's iterative. They're gonna then collect the data a second time, and then send it individually again to each expert and ask them to modify their answers until, and they're gonna repeat this until they reach somewhat similar or equal, like similar predictions. Of course, there are gonna be some predictions that are different, but they're gonna take the majority. So until they all agree on number, then they're gonna take that number, and based on that, they're gonna put the product and put the have the resources for the product based on these predictions, like the layover and stuff like that. So this is the Delphi method. I think it's very interesting. Also, there is the iterative group process, continue until consensus is reached. So these are the different types. So yeah, so it continues until consensus is reached. Then there is the third type, which is Salesforce composite. So it's estimates from individual salespersons reviewed for reasonableness, then aggregated. And this is like estimates from individual people. And but the thing is that maybe this is a one way to, of course, do the thing, and this is one way to get some reasonable predictions, since salespeople do sell these products and they have more of a sense of what's the customer is wanting. So yeah, so it's reasonable. But the thing is that salespeople tend to give numbers that are usually less than what they can sell. Yeah, so they can give numbers that are usually less than what they can sell, and this is basically why does this happen is basically for the commissions. So salespeople, they want to give numbers that are less than what they can sell. So if they don't meet the numbers, so So they made sure that they are going to meet these numbers and get a commission. So for example, if a salesperson knows that he can sell 5,000 products, he's gonna say that the forecast is 2,000. This is because if he says 5,000 and he doesn't meet 5,000, then he's not gonna get the commission. However, yeah. So, but if he says that that he can sell 2,000, and then 2,000 is an easy thing, and then for him, and then he's gonna get the commission. So that's one disadvantage of it. But an advantage is that salespeople are in the field. So, and there is the fourth method, which is market survey, and this is directly asking the customer. Okay, so now we're gonna go over quantitative approaches. Some of the quantitative approaches are the naive approach, moving averages, exponential smoothing, trend projection, and these are time series models. And then we have the linear regression model, which is an associative model. So these are all quantitative approaches. So starting with time series forecasting. So time series forecasting is a set of evenly spaced numerical data obtained by observing response variables at regular time periods. And the forecast is based only on past values, no other variables important. Okay, so basically time series forecasting is obtained by observing the response variable at regular time periods. So for example, I'm gonna observe sales every month. I'm gonna check how are my sales every month, or for example every day, every week. So every week I'm gonna check how were the sales last week, and then next week I'm gonna check how's that week, and so on. And also we can have every month. We can have also many different ways or many different periods in which we can forecast for time series forecasting. And also we have forecast based only on past values, no other variables important, and this is another feature of the time series forecast, and it assumes that factors influencing past and present will continue to influence the future. So it assumes a stable environment. It's very important. Stable environment is very important because in general environments are not stable, but we are assuming a stable environment just to get a good kind of good approximation of forecasting. So which is the best that we can get. So for time series components, there are 4 different components. They are cyclical, trend, seasonal, and random. So these are the 4 time series components, and we're gonna go through them. So, and this is this is a perfect example of the 4 components. So as you can see, a trend in general is an upward inclination, or a downward can be an upward trend, a downward, or maybe no trend at all, just a straight line. So yeah, so it's like the overall shape of the graph or of data where are they going. And very important thing, if you want to forecast, you need to plot. If you want to do very good forecast, plot is key. It's the most important thing of forecasting, most important part of forecasting. So yeah, so also we can see that there are some seasonal peaks. Okay, there are some seasonal peaks that happen at some specific times, and there is cyclical changes that happen frequently, like let's say every season, or let's say every year, or every quarter, or every Black Friday, we expect something, or every beginning of the month we expect something. At the weekends we expect something. For example, for restaurants are crowded at the weekends, and this is something that's cyclical. It happens every cycle, so this is cyclical. However, for season now, we can say for umbrellas tend to be sold more during the rainy days or the rainy season, and this is a seasonal thing, but we cannot predict exactly what's gonna happen. Yes, there is a specific period in which rain happens, so during the winter months. However, we can't predict exactly at which day and which week of the month, so that's why it's seasonal. However, cyclical is something that happens you can predict it. Like, we can predict that's gonna happen this every week, this specific week of the year, or this specific month of every year, this specific week of every month. Okay, so as we said, Black Friday, Black Monday, like, Christmas, or yeah. And so also we have sometimes some random variables that we cannot really predict or have any insight on, and these are, like, as you can see here, some random variable. Okay, so covering now the first approach of the quantitative approach, which is the naive approach. The naive approach is as the name suggests, is very naive. It assumes that the demand in a period is going to be the same as the demand in the second period or the next period. So if a month sales are the last month's sales are 50, we are assuming that the next month's sales are going to be 50 items of the product. If last year was 5,000 products, next year are going to be 5,000, and so on. So this is the naive approach, and usually it works, and this it's a good starting point, because sales tend to not differ very much month from month or year from year, or like in different periods. They might differ, like, for some very exceptional events, like, a very high steep upward trend or very steep downward trend possibly. So these can affect, but for our purposes we can say that it's the thing about it is that it's efficient. So if I just predict based on past data that's gonna be the same, it's very efficient to do, and it costs almost nothing. It's cost effective. So that's the advantage of naive approach, but it might not really be representative of the overall company's state, to say. And the next one is the moving averages. So it's a series of arithmetic means. What is an arithmetic mean? Basically, it's a sum of periods divided by the number of those periods. So for example, if we're gonna take moving averages for the past 3 months, we're gonna add the let's say sales. So we're gonna add the sales for the last 3 months and divide it by 3. And this is gonna happen every month. So and it's helpful. There is no trend overall. Okay, so yeah, so basically if you can illustrate this, okay, yes, this is an example. So here you can see that for Apple, if we wanted to predict the sales for Apple, we can basically take the moving average of the past 3 months, and this can change. We can have 3-month moving average, 6-month, 10-month, 1 year moving average. We can have different moving averages, but here we chose to have 3 months. So we have here for 3-month moving averages, we're gonna add the sales of last 3 months and divide them by 3, which gives us 11.2 over 3. This is the predicted sales for April, if we wanna Now, if we want to have the moving average for May, now we're gonna take the average of the months before May, which are April, March, February, add them and divide them by 3. And by that we get a prediction for May. If we want for June, we're gonna do the same. We're gonna add the past 3 months, the sales for past 3 months, and divide them by 3. July, August, September, all the same. We're gonna add the sales for the past 3 months and divide them by 3, or the number that we choose to have. So this is basically the moving average, and it's often used for smoothing since it provides overall impression of data over time. So, and we can choose the period that we want. However, there is a problem with the moving average. So the moving average in general just sums the past period that we choose. Okay, so let's give you an example. So for instance, now we have, let's say if we have a trend, we have an upward trend. Okay, so let's say we have an upward trend, and then if we have an upward trend, that this means that the sales for the last month are not going to be the same as the sales as in the past 2 months before the last month, or the month before the last month. So for example, if we have an upward trend, so the sales in March are going to be more than the sales in February, and the sales in February are going to be more than January. So this in the regular moving average is not accounted for. That's why the moving average is helpful only if we have no trend, like a lesser trend or no trend. But if we have a trend, then this is not going to help us, because basically what the moving average is taking 1/3. So for our example, this is 1/3 times 10 plus 1/3 times 12 plus 1/3 times 13. This gives us the moving average for past 3 months. However, if we have a trend, this will not be accounted for because the weights are the same. For each month, they have the same weight. Now, if we have an upward trend, what are we gonna assign the weights? Are the weights okay? And before that, for that reason, if we have an upward trend or a downward trend, we have the weighted moving average, and the weighted moving average is used when some trend might be present. So, and for an upward trend, what do you think will be the weights of the last month? So for our example, we want to predict for June. What do you think the weight will be higher for which month? Is it the month before June directly, or the months that are like March? Is it going to be higher for the months before June or lower? It's gonna be higher. It's gonna be higher for the last month. For the month before, like the latest month, is gonna be higher. So we can, for example, for June, we can say that we can give May a weight of 1/2, and then April we give it a weight of 3/4, and for March we give it 1/4, something like this. So the month that's directly before June is gonna have a higher weight if we have an upward trend. Now, if we have a downward trend, then it's gonna be the opposite. It's gonna be the opposite. So the month before June is gonna have the lowest weight, and the first month in the weighting average calculation is gonna have the higher rate. That's exactly what the weighted moving average is used when there are some trends, and it allows us to have weights based on experience and intuition, of course. and based on the trend that's happening and the demand. So as you can see, this is an example of the weighted moving average. If we wanna do it for April, we can easily multiply each year. So in this example, do you think this is an upward trend or a downward trend? The first month, the latest month has a higher weight. The weight is 3. The month before it has a lower weight. The month before it has the lowest weight. So this is an downward trend. This is an upward trend. Okay, so the demand is increasing since and this can be concluded from the weights. This can be concluded from the weights. The latest month have the higher weight, and the month before it has even higher weight. The first month the month before it has a lower weight, and the month even before it has a lower weight. So the weight increases, and this means that we have an upward trend. And this is gonna give us for an upward trend, it's gonna give us a higher number. So for our previous example, we got 11 and 2/3. Now we are getting 12. So we are overestimating since we have an upward trend. So we have the right to overestimate. And also this note here that we divide by the sum of the weights. So here 3 plus 2 plus 1, which is 6. Okay, so these are the weights. So last month 3, last 2 months 2, 1. And this is applied on the whole month, the weighted moving average, and this is also assuming an uptrend for the whole months of the year. So it's giving the last month higher weight than the last 2 months or the last 3 months. Okay, so there are some potential problems with the moving averages, and these include increasing the value of n could lead to smoothing of the forecasts and makes it less sensitive to change. So it becomes like a vague, linear prediction. So it's not like something that's predicting real life or predicting real sales. In real life, we have sales that depend on season, sales that depend on cycle. For example, in Ramadan, sales for products and goods, what happens to them? Increase consumer products because people tend to buy more and cook more, and especially in the region, in the Arab world. So, and it usually does not forecast trends well, and it requires extensive historical data. You can see this is a graph of the moving averages. Here this is a graph of the actual sale, and this is a moving average. You can see the difference between the moving average and the weighted moving average. So there is a slight difference. And I think the weighted average is more representative since there is an upward trend, so it makes sense. At least for the first part, and then for the second part, maybe we can change the weighted moving average. And that's all for today, or maybe we can go through something. No, I think that's all for today. Okay, So we're gonna stop at the moving averages. That's all for today. Thank you for watching this video. Leave me a comment if you have some questions, and thank you for watching.